Welcome everyone to our webinar, Can I use Benchtop in my lab? I'm very happy to have all of you here. My name is Schwenk. I'm one of the founders of HQS Quantum Simulations. And at HQS, we are building software for spectroscopy. And our main product is HQSpectrum, a platform for NMR analysis based on quantum mechanical predictions. And what is unique in our platform is that our predictions are of high quality for the whole frequency range. So you can also use our predictions in Benchtop, and that's why we are here today. And together with our partners from Merck and Q-Magnetics, we give you a broad picture of what is possible in the field today and what will be possible soon. An important part of today's session is our hands-on session where you can draw your own molecule and see how it would look like at benchtop frequency. We will start with a presentation by Coralie Leonard from Merck, presenting ChemisTwin and Merck's work towards digital certified reference materials in NMR. And this talk is followed by a talk by John Frost from Q-Magnetics, presenting their 125 megahertz benchtop machine that combines high resolution with low cost. And following, my colleagues Konstantina and Florian will present HQSpectrum and how it can enhance your benchtop workflow. And then we will dive into our hands-on session where you can test your own molecules. You can draw your molecules, see how they look like at different benchtop frequencies, see if you can distinguish important features, and also try out different workflows that will enhance your benchtop experience. Before I end this short introduction, I will shortly tell you where HQS is coming from. So we have founded HQS in 2017 with the goal to bring the quantum computer to an industrial value. Quantum computing is far away from today's topic of our webinar, but I will explain you a bit the connection. So we are searching for quantum computing use cases in the spaces of chemistry and material science. And in our work together with Merck, we have realized that NMR spectroscopy is a very promising use case for the quantum computer. If you now want to really show that the quantum computer is superior, you need to know what you can do on a normal computer. And that is why we created a software tool that can simulate NMR spectra on normal computers. And this software tool is so efficient and so powerful that we can already now bring value to our customers based on this software tool, which runs on normal computers. And this is the basis for HQSpectrum. And still we are working on the connection on how the quantum computer can in the future enhance the analysis of NMR spectra. So if you want to stay up to date on this very exciting topic, please follow us on social media, on LinkedIn, for example, or YouTube. Here we are regularly posting updates on how quantum computing and NMR spectroscopy is connected. But today we are talking very hands-on on using HQSpectrum to improve your day-to-day work. And now I hand over to Coralie for presenting the work of Merck in ChemisTwin.
Thank you. Let me just share my screen. So what I will do today, in the 15 minutes that I have, I wanted to explain to you our concept, why we are doing this, and then I will also explain the limitations we have today and how we are working together with HQS to overcome the current limitations and opening the concept I'm going to present today to benchtop NMR as well, and why we are doing this. And for some that may not know, Merck is actually one of the leader producer of certified reference material in the world. So we not only distribute some famous NMI reference material, but we also produce our own. So we do have that knowledge on how to manufacture highly pure compound. And you will see why I'm starting the story here. But again, for the one that don't know, what we've always said when we manufacture CRM is that it's not the powder or the liquid that you have into the vial that matters. It's the data you can get from it. It's what's inside the vial. That's is a way to have a good quality and reliability of the result you are generating with it. And this is what we are really providing to our customer buying those reference material. For certified reference material, this is an even higher level of trust where the identity has been certified. We are audited to ensure that the way we are certifying our product is correct. So you can trust the data that you're going to extract from those materials. It's really the confidence of having that right molecule that can turn your test into a usable, traceable results. And that made us think to another industry, and this is how we like to illustrate our concept. Our researcher thought about the music industry. And they thought, well, actually, what we are giving to our customer with this certified reference material or the reference materials, this physical product, is very much like in the days where we were listening to music on CDs or cassettes for the older folk like me. We didn't really care about the CD or the physical material we were receiving. What we cared was to listen to the music, to the data. So we moved from purchasing a physical product to purchasing an MP3 or MP4, and then even moved to streaming platform like Spotify or other type of streaming platform where we are consuming directly the data we need and don't even need to own any music anymore. And those are now more and more getting embedded into entire ecosystem of different applications that we are using. And we thought, what if same thing happened to reference materials? Because our customer don't care about the physical product, they care about the data they can get from, and they care about comparing their own data to the reference data. Could we build that? And we decided to start with NMR and build ChemisTwin portal containing what we call digital reference material. Now, Merck is now also building some other applications where we want those applications ultimately to work into an ecosystem, but we're not there yet. I will go on this one pretty quickly, but there is different level of reference material. I'm happy to share those slides later for the one interested. And we are producing all the level of reference material from region grade that some people can use sometime as a reference, but shouldn't, to analytical standard. This terms is less controlled. It's under ISO 9001, to the one that you see in yellow at the top, reference material and certified reference material. The highest level of trust comes from the NMI reference material or the pharmacopoeias. These we could not produce. We have to distribute. Know as well that depending on how your lab is audited or certified, it may be mandatory for you to use those reference materials. And this is where we would like to place digital reference material. That is in this higher level of trust where we can give, if possible, directly the data and not just the physical reference material. So we built that platform, ChemisTwin. This is what we consider an MVP. So for us, it is something that is ready for use, but that we are still building. It's still hosted into our R&D department. It's still something that we are improving. It's not a fully finished product. And we've built that concept of digital reference material that we launched about 3 years ago. And the way we define digital reference material is digital record of a physical reference material that have been produced under ISO 9001 and of a physical product that is sufficiently pure and sufficiently characterized. So we still want for these DRM in our definition, having a clear link between a physical, highly pure, well-characterized material and a reference data set that we obtain from that material. This is important. Ultimately, later, we also want to move to data set that could be purely simulated. What we are doing in NMR is the sample preparation and the spectrum acquisition. This is something you of course still have to do in the lab. So imagine you're preparing a new batch of a production. You prepare your sample, your sampling procedure to check the identity or to check the quantity. You acquire in NMR spectra, and then you upload it into our platform. And from this point, everything is automated to do all the post-processing of the spectra. The comparison with our database is also automated, and our database of digital reference material. And then you get a result at the end that you can approve and say, okay, this is the compound I'm happy to have, and I can confirm the identity. We also have this for quantification. And I wanted to show you a quick demo, or at least what it looks like in real life. I need to share again to switch the screen. So this is the platform, and this is how it looks like after you log in. Let's say you've just run an analysis of a compound that you need to check an identity. What you're seeing here is what is coming from our own production of reference material. So these are real life files. Let's say here I want to do a qualitative. So this is my NMR spectra for people doing NMR. I guess a lot of them are doing NMR in this call. This is a rather clean spectra because we are operating with certified reference material of higher purity, but that's what we have for now. So I've entered my sample. Now I want to check that this sample is indeed disperse orange. And this is where we have this database of what we call digital reference material already embedded into ChemisTwin. And we have around 3,000 of such experimental spectra with all the NMR, the experimental NMR parameters informed here into the database already. You can view the details. And like I was saying earlier, you know from which exact physical product this is coming and which batch. So we keep that traceability of where that measurement is coming from, how we acquired it. So you can see this one is on a 400 megahertz, and this is where we are collaborating with HQS, is all our instruments are high field. And I can say, okay, this is the correct molecule I want to compare my sample with. So I add it to the analysis and I run the analysis. Now the ChemisTwin portal will compare my results, my sample, to the reference data and will give me a recommendation. The recommendation here is that the match between the sample and the reference is sufficient to confirm the identity as much as you can with 1D NMR. Below you can see the different spectra and how they've been compared, the table of assignment between the reference and the sample, and all the information about how you set up this. You don't really need, once you validated this tool, and this is what we are starting to do with our internal QC, you don't really need to look too much into the detail. It's mostly important that your match factor is okay. So this is a first screening to detect if there is an issue. Here I see none. I will approve the analysis, electronically sign it. And once I've done so, I have to do it twice because we have a 4i principle here. I can then issue my analysis report as a PDF, or it is also in here available, that my compound was indeed verified and correct. And I can share that report via email, whatever I want to do with it. Now you may think that this is nice, but this is more for the future to have this into a more regulated environment. But I think this is actually coming sooner than we think. And let me go back to the presentation. Actually, in the world of NMR, USP made the first step into getting digital reference material recognized as an official standard. They have changed their Chapter 11 in December last year to include the definition of digital reference standard by USP. So we know that in this year, very likely, USP will now produce official compendial standard that will be in the form of digital reference standards. Their interpretation is very interesting, the way they defined it, because they include digital data set that have been acquired from sufficiently pure material, but they also include calculated spectra, as long as you've proven that the calculation and the fine-tuned model are sufficiently efficient at predicting such molecule. So this is actually covering quite a range of application, and this is covering our partnership with HQS. At the moment, ChemisTwin limitations are multiple. We only offer high field NMR because this is what we use internally for our quality control, and therefore we have experimental data mostly on high field NMR. So HQS is working with us so we can translate this, or we can compare the high field NMR with benchtop NMR. So you can then come into ChemisTwin, input your low field NMR database from Benchtop and compare it still to our database of high field. This is what's going to be released pretty soon onto ChemisTwin. So you will upload it. This will be sent to the fine-tuned model that we are developing together with HQS on their technology, compare it to our database, and then send it back to ChemisTwin. What we are going to work also in the near future together on is mixture. Mixture work well when you're doing manual processing with NMR spectra tools. But when we want to fully automate, like you've seen it into ChemisTwin, where I want in 3 clicks to have my response, is it the right compound or not? And it's a mixture. That doesn't work really well. This is where we'll really need QMSA models from HQS to actually try to solve this when we have mixture, and especially if this is in Benchtop. We also want to combine these two, benchtop and mixture, for the quantification as well at a later stage. So today you can use ChemisTwin for quantification on high field, but we want to also offer that at a benchtop level. And why we are doing all that with HQS together is we want to make NMR more accessible. This in particular for routine testing. We think this is a fantastic method to quickly check, do you have the right structure or not? Do you have the right quantity, to reduce the number of chemicals you need to use in your lab, because it is a technology that uses very little chemicals. And if we can give you a powerful DRM database to use, then you don't need to use as much reference material. So it's also saving those chemicals. The instrument benchtop NMR are getting much cheaper and smaller. So they're getting accessible to a lot of people. And what we want to bring with a platform like ChemisTwin to automate the interpretation is to make this easy and accessible to any analytical lab technician, and not having to have an NMR deeply trained scientist that can interpret the result, but really more a plug and play technology in the future. So that's what we want to achieve together with HQS, and why we value this partnership very much.
Yeah, thank you, Coralie, for this great introduction of ChemisTwin, and also mentioning our work together. Then we will continue with John from Q-Magnetics.
Well, thank you, everyone. I'm John Frost with Q-Magnetics. We are a benchtop NMR manufacturer out of Boulder, Colorado in the United States, and been working with HQS and are really excited for this partnership and our role in providing some real-world hands-on data in order for us to really investigate just how effective this is. But today I'm going to let the workshop portion speak to that aspect of it, and I'm going to focus on our instrument specifically and some of the application spaces that we find very exciting and interesting. So if this is your first interaction with benchtop NMR, these are relatively small systems. They're all permanent magnet-based systems. The first commercial product was released in 2011. And since then, there's been about a dozen different models that have come and gone throughout that last 15 years. But these are relatively small instruments, ranging from about 10.5 pounds or 5 kilograms, 4.5 kilograms, all the way up to a little over 100 kilograms. So they range in size considerably, but in general, they're all just intended to be sited on a standard laboratory bench. Over this last 15 years, we at Q-Magnetics have come to believe that benchtop NMR is best suited for making NMR accessible to everyone. Its real utility is in the convenience of having it right there on your lab bench and getting that rapid access to the powerful NMR data. we do not believe that it is a replacement for high field, but that it is an excellent complement to high field. And this is an area where we think the partnership with HQS can be really exciting. Because in the past, we have, as every NMR we have this strong relationship between the field strength and size of the magnet and the application space that practical applications will succeed, both due to sensitivity restrictions, but also the spectral dispersion. As we go to lower and lower fields, we get more and more spectral overlap. At Q Magnetics, we've tried to minimize that to the extent we can by creating a very strong 3 Tesla magnet, but it's still going to be limited compared to a 400 or 500 megahertz system. There are other applications, of course, where using a high field is simply impractical. So reaction monitoring, oftentimes you're not going to be able to bring your chemistry to high field. There's other users. The safety situation in the NMR lab may not facilitate your chemistry. So being able to bring the NMR to your chemistry is an area where we see a lot of excitement. And then one that is fairly unique to our particular instrument is as we've started to explore the hyphenation of NMR technology on the bench to other analytical instruments. Our partnership with HQS we find very interesting insofar that these simulations can open the door to operationalizing some of the analytical methods built using high field NMR data. So you maybe have that high field, or you send samples out to a high field in order to do the initial method development. And once you have that information, using a combination of that data, tools like HQS, in order to translate that high field data into what we would expect to see at a low field, so that you can then replicate it on a regular basis in a more cost-effective and time-efficient manner. So here's just a quick rundown of some of the features of our particular instrument. The instrument itself, it features a 3 Tesla, 125 megahertz magnet. One of the things that's really unique about our system is that we do not use 5 millimeter NMR tubes. Instead, the sample is introduced through one of these identical port plugs, and these use standard HPLC style fittings. And the sample flows along what is essentially this black line here internally through a PFA flow path to the magnet and the active volume coil. This has a number of different really exciting advantages, including unrivaled shim stability. We don't change the sample geometry when we change samples. And so there's little or no sample-to-sample shimming required while maintaining that high degree of shim. It also lets us transition between walk-up use, where you may introduce a sample manually via an injection, and then simply by screwing in a peak thumb screw with connected to whatever supply line that you might be running, may it coming from a valve or a pump or another piece of analytical equipment. As fast as you can make that transition, typically just a matter of seconds, allows you to physically convert the instrument from automated, hyphenated use back to manual walk-up use. And it's very easy to go back and forth between the two. It's very robust and reliable, and building off that simple transition between both the manual walk-up approach and the automated hyphenated approach, we have software that supports that as well, both internal software to just automate routine experiments and stack experiments through arrays, but also to integrate with additional outside systems. And I'll explain and show you some examples of those too. And as was alluded to, the cost of these systems has come down considerably as well. So this particular system has a very accessible price point, far below what you'd expect using the old standard of assuming about 1,000 US dollars per megahertz. We're significantly below that. In this application space, NMR is, as we all know, a very, very powerful analytical technique. And essentially, if you have a measurable nucleus, you have a potential application. And we've seen that particular application space for benchtop NMR grow and grow as the instruments have become more powerful over the last 15 years. And a few that we're going to focus on today, just some pharmaceutical applications, reaction monitoring, hyphenation. But we've worked with everything from food, beverage, flavors, fragrances to fuels, petrochem, nuclear chemistry, renewable energy, polymers, analytical and forensic science, pretty much anything under the sun. This first example is comparing a 125 megahertz reserpine sample to 300 megahertz data. And you can see that in this particular case, and we selected this particular compound because reserpine is an antihypertensive pharmaceutical agent, but it is also often used as a reference standard for the specifications on different mass spectrometers. So you can see in this case, while there's certainly significantly more resolution and sensitivity here, we do see the same spectral features throughout. So in the aromatic region, we have the exact same information content. It's really that aliphatic region below about 4 ppm where things start to get very crowded. And this is an area where having HQS's simulation capabilities really helps us understand and make those last few peak assignments. Because not every sample is quite as cooperative as in this particular example with a antibiotic everybody's familiar with, amoxicillin. And you can see in this particular case, while at these concentrations, we do see quite a bit more noise than a high field would experience, which, that tracks with the physics. As you go to lower fields, you do lose sensitivity. But while these instruments, they do have a great deal of analytical power available to them, they are still bound by the physics. And some applications are going to be very straightforward, and others like reserpine, you're going to start to see some of that overlap. Another application space would be reaction monitoring, and here we're just looking at a very simple Fischer esterification. But what's interesting here is not so much the chemistry involved, but the ease at which both the physical hardware and the software were able to be brought together and work as a single unit. So in this case, I had previously this is an SSI from Teledyne M1 class pump, and this is just a 4-port 2-position switching valve with a universal actuator from Vici Valco, and was able to bring these pieces of equipment, which I already had on the shelf. They're about 15 years old at the time that this particular work was done. Pulled them off the shelf, brought them over with the QM125, and not only was the physical connections very straightforward, you can see those little thumb screw HPLC peak fittings, but the software was able to bring everything together very quickly, and within a half hour, I had a fully automated reaction monitoring system that I was able to use in order to acquire this data, which from a pedagogical perspective, having previously taught in university, I found very interesting insofar as we run Fisher esterifications with every organic chemistry course on the planet. And we tell them that this orthoester intermediate forms, but the students never get to observe that. And in this particular case, while we're monitoring this reaction essentially in situ, we're able to see not only the formation of the expected methylbenzoate product, but the stability and formation of the orthoester intermediate and how it is stable in the reaction mixture, and upon workup then collapses down into the final product. So there's a lot of utility in this, both for teaching, but also for understanding your own industrial chemistry as you move forward with a product. Maybe you're doing kinetic studies, maybe you're doing quantitation work. That's all within the bounds of this technology. There's another example of a Diels-Alder reaction monitoring example, kind of one of the same. Now, this is where we really start to get unique to the QM125 insofar as our flow-based sample delivery and very flexible software interface allows customers to do a lot of different things. And so early on, we had a customer who had an old Agilent 1200 HPLC system, and the actual LC side of it, the chromatography pumps, were no longer operational. However, the auto sampler for that 1200 was, and they really wanted to run a large number of samples every day, and so they were curious as to whether or not they were able to use their old Agilent 1200 HPLC auto sampler as their auto sampler for the QM125. And in fact, they were. Took a little bit of work as this was the first application of this technology and the software, but we were able to bring that together pretty quickly. And the customer is happily running those samples. But it really got us thinking about what's next possibility. And if we can run an auto sampler, can we run the whole chromatography stack? And in fact, we just published a paper earlier this year looking at the use of gradient-based separations for pharmaceutical compounds using high-performance liquid chromatography hyphenated to our 125 megahertz benchtop NMR. And so it really starting to bridge the gap and make not just benchtop NMR, not just be an analytical tool for walk-up single application samples, where we're just trying to replicate how we treat the majority of high field NMR spectrometers, but on the bench. Instead, we're trying to expand that application space and the different ways that the actual instrument is utilized, not just as a standalone piece of analytical equipment, but as part of an analytical system, whether it be an HPLC NMR or NMR mass spec, or even part of a automated reaction synthesis system. So where they're running either a flow-based synthesis process or some other analytical automated lab and integrating it into that. And then of course, just gotta throw in a little plug for our particular software, which we use to control the instrument, QM Control. Data processing is not handled by QM Control. We focus on the instrument control and data acquisition. Data analysis is done in any third-party software package of your choice. We partner with MNOVA. However, it is standard JCamp DX6 file format, so anybody can open these data files pretty easily. And lastly, we'll just kind of let you know about some of the other, interesting aspects of the instrument. We do have a microliter sample kit that allows the instrument to be used with very, very low sample volumes. The standard configuration uses about 0.3 milliliters of sample. Our microliter sample tube kit allows the use of as little as 5 microliters of sample, but So if samples are availability limited, very expensive, very dangerous, we can work with very, very small volumes in order to keep everybody safe and keep it accessible. I mentioned the experimental arrays and the open source software and APIs already. So that kind of just a basic introduction to Benchtop NMR, the technology, our instrument in particular, and some of the unique ways that this technology is really expanding how NMR is used. All of these things have been done with high field instruments, certainly. However, they're not done regularly because high field time is so expensive. So, and there are safety considerations. So you're not going to set up reaction monitoring experiments on your high field on a regular basis. However, a benchtop system is ideally suited for reaction monitoring, just as one example. Hyphenation to other equipment, that's another example where the high field, it's simply logistically challenging in order to accomplish that, but benchtop NMR with the advancements that have been made, and now these additional capabilities that are being brought forth by HQS are allowing us to further expand those other application spaces as well. So with that, I'll hand it back.
Yeah, thank you, John. Invite now Konstantina to share, and we will go over to present the capabilities of HQSpectrum.
Thank you very much. So good afternoon also from my side. I'm Konstantina Alexopoulou, the sales leader at HQS. And as you have already heard, NMR remains one of the most powerful analytical techniques for the structure verification and elucidation. However, the NMR experts still face several challenges in their daily workflow. And for us at HQS, it was really important from the beginning to understand these challenges in order to develop a solution, a software solution that directly meets the needs of the NMR community. So from different discussions and surveys, we heard really often that spectrum interpretation is often time-consuming, especially for complex samples. Many of the scientists still rely on manual workflows. The existing databases and the prediction tools that you are using have many limitations. And finally, it was really clear that the users, the NMR users, would like to have a tool and find an easy way to compare the predicted with the experimental spectra and quickly verify whether the proposed structure matches the data or not. So we identify four main challenges in today's NMR workflows. First of all, manual interpretation is often slow and heavily dependent on the expert knowledge. Second, low-field instruments can struggle with single overlap and complex coupling patterns. Third, the prediction tools that have been used do not always provide the reliability and the transparency that the users need. And finally, when we come to the topic mixtures analysis, this becomes extremely difficult. So all these challenges together create, I could say, a headache for all the researchers in both the research and on daily analytical workflows. So taking all these challenges into consideration, we developed HQSpectrum. HQSpectrum is a platform that bridges the gap between the molecular structures and the spectral interpretation and makes the NMR analysis faster, easier, and more reliable. HQSpectrum uses the phantom-inspired technology to generate accurate spectral predictions directly from the molecular structures, and it doesn't replace the expert knowledge, but it makes the opposite. It enhances the expertise by speeding up the interpretation process and making advanced NMR analysis accessible and efficient. So when we start working on the workflow, we identify at the end that it consists of 4 simple steps: predict, adjust, verify, and report. So HQS Spectrum at the beginning predict the NMR spectrum from a proposed molecular structure, then compare it with the experimental spectrum. As a third step, it verifies verifies the structure, and at the end automatically generates a report. Its verified spectrum is added to a knowledge base, and that can be helpful for the future and makes your analysis faster and more reliable. While we start working on this tool and on the workflow, generic workflow, we identified that 3 key workflows that can be used to extend the capabilities of the low field benchtop NMR. In the first one, you can use HQS Spectrum as its own, as a standalone platform solution, and you can predict the NMR spectrum from your molecular structures. This allows the users to assess whether a compound is suitable for benchtop NMR analysis before performing any measurements. In the second workflow, we combine our tool with the hardware, in our case, the QMagnetics benchtop device. And in this case, users can perform the structure verification directly on the low field benchtop instrument. So HQS Spectrum can help you to overcome the lower resolution of the benchtop NMR device by matching the predicted spectra with the experimental results. So now for more complex samples, workflow 3 takes things a step further by incorporating high field reference data into the process. This can be done in 2 different ways. In the first way, you can use as a starting point the ChemisTwin's curated and assigned high field reference data. And then you can combine, HQS Spectrum combines this data with its own prediction methods to generate low field reference spectra, which are then can use directly with and compared with benchtop measurements for automated structure verification. In the second option, HQS Spectrum acts as a standalone platform. So you can use a high field spectrum either measured or uploaded, and this can be aligned, verified, as saved as a reusable digital reference. Then later, if you would like to continue your experiment on a low field, you can take this reference, the spectrum, convert it to the corresponding low field equivalent and use it for direct comparison with a benchtop measurement. So as you can see, you have different options, depends on the complexity of your molecule, and you can choose the workflow that best fits your needs. But you have to keep in mind that using HQS Spectrum, and HQS Spectrum provides you a complete scalable solution for structure verification on benchtop NMR systems, whether you are starting for a molecule structure, a predicted spectrum, or a curated high field reference. So these 3 different workflows represent a real shift, because before HQS Spectrum, overlapping peaks and limited resolution often force laboratory to rely on high field facilities. The standard tools struggle with complex mixtures and crowded spectra and data. And as you can see, benchtop NMR was already accessible, but it wasn't powerful enough. Now we can say that HQS Spectrum changed that because through adaptive fitting and shift correction, it enables for more reliable and confident analysis directly on the benchtop device, and users can analyze complex samples with greater confidence and efficiency. That was a short introduction, and I would like to hand over to my colleague, Florian, who is the product manager for HQS Spectrum, and he will walk you through the workflows and the hands-on session. Thank you very much.
Yes, thank you, Konstantina. So you should now see HQSpectrum. And as we did tell you in advance that you are able and you are allowed to create an account, which we will then use, or you can use in our now elongated hands-on session to just work with the tool, check it out, and we will be your support whenever you need something from us. You can directly contact me and or just raise your voice whenever you want to. So this is how our tool look like when you start and log into the platform. And as you see, we also have this mixture analysis already in the overview, which is not yet ready, but as Coralie discussed, we are heavily also working on this part. So up until now, we have the structure verification workflow, which can be started when you using any molecule from either our list. You can also import your own molecule parameters, which is also a thing you could do if you have a really large molecule. You could also import your parameters directly here. Or the really cool thing you can also do here is that you use this draw and predict tool from our side, and I will try to draw a molecule which any one of you might know. So I will start with drawing something like this and this. If I'm correct, then I need another one here. I will change this one to hydrogen. Yeah, oxygen. And here too. So I drew ibuprofen, and as you might not know from other tools like this, you can quickly clean up your structure, and then using this clean up structure, you are able to generate the NMR parameters. You give it a name. As you can see, I did that. Sooner or later appear. Yes, and you can also see that you can select here hydrogen and or carbon shifts, and also the couplings between us. But to simplify it, we would just use 1H. Currently, we would generate the parameters. And after we calculated this, which should not take too long, now the parameters calculated successfully. I can go back to this overview. I can quickly reload the molecules list. I have my data in it, and there I have the ibuprofen, which I drew already. And then I can select in our overview, I can just select the frequency. I have selected 125 megahertz, which is corresponding to the machines John already showed us. I can then simply calculate the spectrum, and the spectrum should directly appear in this overview on the right. And now I can, with our tool, for example, do things like highlighting individual peak contributions, which helps you a lot when identifying more complex molecules, and or will also help later with the analysis of mixtures. This is we are able to do this due to our DFT approach, and due to then also using for empirical predictions this database of DFT parameters. So we are able to calculate for each individual spin the individual contributions to the NMR parameters, being chemical shifts and J couplings. And this would also be the first workflow that also Konstantina showed you. You can enter whatever molecule you would like to. You can simply draw it and or enter it by means of parameters and or choose it from the list, and then simply calculate it. And the next steps you could do then would be things like, for example, importing a spectrum, which you can then use to compare with your prediction. and evaluate or verify your structure. But to not complicate anything even more, I guess this is even a lot of new buttons and new things to investigate. I will more encourage you to look over to the site HQSpectrum.cloud@quantumsimulations.de, log into your account, and then test it yourself.
So I think many people have now created an account. I think we can continue showing a bit more advanced workflows.
I will unshare this overview and will share again my screen of the HQSpectrum overview. And I already opened camphor, this molecule, which I will calculate with 500 megahertz because I have the experimental data for. And as you can see, it's rather quick to calculate. Then I will import the spectrum, which should be up in a second. So again, I have here this spectrum. I know this one is the chloroform peak, and this one here is the reference. What I can also do is, for example, re-referencing. If I see it, for example, here, this is a small deviation of the thing. I could correct this briefly with a global shift. I could again trim this to the region which is interesting for me and compare the spectra to my predicted spectra. And as you can see already, the prediction is rather good. You can now, what I showcased last time or explained earlier, I can compare that to the original one, which currently tells me there is no match. And now I have multiple opportunities to do to improve on this matching, which is by eye maybe also rather good, but I can improve on it with two options of an auto adjustment tool, which we have a really precise one and a fast one. I will just briefly use the fast one for the matter of time, and I see that there is immediately a blue line occurring, which is the new refined spectrum. When I recalculate this, it now shows me that this adjustments led to a really good overview, and you can also directly see this in the spectrum comparison, which is now a match for this spectrum. And what is really cool now, I can save this as a reference. I can say, okay, this is now my camphor reference from today, which is the 22nd of June, and I measured it at 500 megahertz, and I can confirm that. And what I can now do is I have this reference then in my overview. I can select this one, and now I can choose, for example, I have now no access to my 500 megahertz machine, but I have a 300 megahertz, or I have, for example, a Q-magnetics machine, a Benchtop machine, and calculate the camphor spectra at 125 megahertz, which will result in a spectrum which looks like this, and I can immediately compare this to a new batch of experimental spectra. So this is a rather a more advanced workflow, but this can also be done by you, since we have in the overview also the reference for camphor in our overview. So you can do this yourself, or what you can also do is you can use your own tools or experimental spectra. So these are the main workflows we wanted to show you today. As we said, there are interesting things ahead. So we are working on this mixture analysis. We are working on a structure elucidation workflow, which essentially is this verification workflow, but for multiple molecules at the same time. So you can identify which is your best candidate, for example. And you can play around now
So people are testing. If you want to also test with an experimental spectrum on benchtop frequency and you have no available, John allowed us to also share the ibuprofen measurement from Q-magnetics. So if someone is interested, just send us a message in the chat and we are able to forward you the experimental data for ibuprofen for you to try out. Yeah, thank you again for participating. Thank you also to John and Coralie for giving this great presentation. Thank you to everyone who joined us today and tested HQSpectrum. We are happy to also receive more feedback from you. So reach out to us via email if you have any feature requests or questions so that we can further improve our tool. So thank you and have a nice day.